Now we're going to talk about the convergence of an infinite geometric series. So here it is. If r is less than 1, so this is the absolute value of r. That simply means that r is really between 1 and -1. That's really what that means when it's the absolute value of r, because think about this being a negative number. And that's okay, because if it was negative 1/2, it would be the absolute value of that, which equals 1/2. So that's what that means. So kind of keep that in mind here. Don't forget about that other side, that negative side. That's truly what that means there. So anyways. So now the infinite geometric series, and here's the infinite geometric series there. And we say it's infinite because of the n there being infinity. Converges, okay? And then it says its sum is, and here's the sum. Now again, this only works when the series converges. And when does it converge? It converges when r is less than 1. So if r is less than 1 there, the absolute value of that, the infinite geometric series converges. So when this r is less than 1, or greater than, well, I should say between -1 and 1. That's probably a better way to say it. Okay, so anyways, so now what we're going to do is we're going to look at a sum that we already seen in the last video. So that sum is, I'm not going to say a sum here, but I'm going to say a series, because we're going to infinity with this one. Okay, so this is the one it was here, 1/2 to the k. So what I'm going to do now is I'm just going to take this and write it out explicitly each term, because I want you to see something here. Okay, so here it is, and it goes on forever. Okay, so we know that this equals 1 from the last video. So what I'm going to do here is I just want to show you using this formula. So one thing to keep in mind here, what is 1/2 again? Remember, that's my first term, so it's a1 plus a2 plus a3 plus ... and that goes on forever. I wanted you to see this here because that 1/2 is really my a1. And my formula calls for a1. So essentially all we have to do to find a1 forever is look at that first term there, k equals 1. When I plug that in, that's going to be my first term. Whatever it is, that's going to be my a1. Okay, whatever I get when I plug that in. So anyways, so now that tells us then our a1 here is 1/2, and that 1/2 goes on top. And then this is 1 minus, and our r here is the thing we're multiplying times itself. And that here is 1/2. So I'm just going to put my 1/2 here. So now I'm just going to do some arithmetic. Now this is complicated arithmetic because it's fractions. Okay, so that's 1/2, and 1 minus 1/2 is 1/2. And 1/2 divided by 1/2, essentially what we do when we're dividing there is we flip the second one and multiply. And I'm just going to write it out that way. You guys can probably see that it's the same number over the same number, so it's 1. But I just want you to get used to the mechanics of fractions here. So that means this would really be 1/2 times 2 over 1, and that's going to be 2 over 2, which equals 1. So we can see how the formula works here. And essentially that's really a cool formula with these geometric series. And it is really strange though, and I've always thought it was, that I can add up infinitely many things here, and it still just equals 1. Now again, I also really like the depiction that I had in the last video, where I had this kind of set up here, and I talked about taking half of a half of a half, and realizing that, oh, I can really see now that if I keep taking half even down there, that it's going to go to 1 when I'm all said and done, when I get to infinity. So that's really the idea here, and then also being able to use the formula to actually do that, because trying to draw pictures out for this would be kind of ridiculous, especially when I got to thirds. Let's say I did 1/3 to the k. That would be awful. But anyways, there you go.